For the backside of this worksheet, we are given the graph of f prime, and we are looking to sketch the graph of a function f. Now, one thing that I want to remind you of is, like we saw on that the first part of the packet, if we know what f prime looks like, that is not enough information to graph f as far as its location vertically. We can get the behavior of f, but we don't know where the graph of f is happening. Okay, and I'm not going to start with this first one. I'm going to hop over here to this fourth one. Label this f prime. Okay, because it's a little bit more straightforward. So we'll start with a little bit more basic one, and then go back to one that's a little bit tougher. Okay, so for this one right here, I know that anytime f prime has an x-intercept, that means that the slope on f is 0, okay? Meaning we have a horizontal tangent line. So because there are x-intercepts here, here, and here, that tells me that f might have 3 extrema. Okay, now I say might because we saw an example on the other side where f prime was equal to 0, but then we did not actually have a max or min, like it was decreasing and then horizontal and then decreasing again. So here, if f prime is negative, then 0, then positive, okay, negative slope to 0 to positive tells us that f has a min at x equals -1/2 or whatever that is, okay? So we have a min here. And then we have here, f prime changes from positive to negative. So positive slope, 0 slope, negative slope. We have a max on f at x equals about +1/2, or maybe a little closer to 1. And then over here, what looks like about 3, f prime changes from negative to 0 to positive again. Negative to 0 to positive means we have another min. So the graph of f has a min, and then a max, and then a min. And again, we don't know what the height of that is, so really wherever we want to put that is fine. Yours does not have to look like mine as far as where it goes vertically. I just need to know that this point at x equals whatever this value is has to be below this one, which will have to be above this one. So I could say, and I'm just going to draw everything up above here, so I'm going to say that right here I have a min, and then here, make that a little higher, I have a max, and then here I have another min. Okay, so filling in the curve around that, I should have a negative slope up to this point, and then a positive slope in between them, then another negative slope, and then another positive slope. So negative slope, okay, so it's coming down, positive slope in between, and actually it gets, since f prime increases and then decreases, the slope of f would get more steep and then less steep, which makes sense as we go back to another extreme, and then a negative slope in between here, and then a positive slope. Okay, so this is a possible graph of f. Now, yours should be W-shaped, but where it occurs is totally up to you. So we could have something with the min down here and the max up here, and another min over here, and it could be something like that, and that would be completely fine, okay? As long as we have the same shape. Vertically, it doesn't matter where that's happening. All right, I'm going to go back to this first one. Okay, so here, this one's a little bit different. It doesn't look quite like a polynomial. I do have one x-intercept, okay? And so here, f prime changes from negative to 0 to positive. Negative to 0 to positive slope means that f has a min at x equals 0. Okay, so wherever I'm going to put that, I'm going to draw mine below this time. So this is going to be a min. Okay, I have a min at x equals 0. Now, to the left of x equals 0, f prime is negative, meaning that the slope of f is negative. So f is a decreasing function. Okay, but it's not decreasing like a parabola. Okay, it's not decreasing like that, because while it is decreasing, as x approaches negative infinity, f prime approaches 0, which means the slope of f would approach 0 as well. Okay, so at whatever height that is, the slope of this curve is approaching a horizontal line. The slope, the value of f prime is slightly negative, okay, slightly negative, but close to 0. So the slope of f should be slightly negative, but close to 0. So I'm going to move that down a little bit more so I don't run into my other graph, but not a big deal if you do. Okay, so something like this. Okay, and it appears that we probably have an asymptote there. Okay, and then on the other side, f prime is positive, so it increases, but then it starts decreasing again. Now, still positive, but less positive, and then also approaches a slope of 0. So increases more quickly, and then starts increasing less quickly, and then probably have an asymptote over on this side. So we have kind of this bird shape, U with the side stuck out. Okay, so something kind of like that would be our graph of f. And again, this could happen anywhere vertically, but it should be the same shape. All right, for the next one, we have what looks to be a polynomial curve again. So we have some x-intercepts. Okay, so f prime has 4 x-intercepts, and it is changing signs at each of these. If f prime is changing signs, then f has a max or a min. Okay, so the graph of f will have a slope that is positive, and then negative, and then positive, and then negative, and then positive. So f should be increasing, and then decreasing, and then increasing, etc. Okay, so right here we have f prime changing from positive to negative. Positive to negative means a max. Okay, positive negative slope means a max. So we have a max at this x value. I'll do mine below again this time. So here is a max. Okay, and then here we have a min, so just somewhere below that value, min. And then here we have another max. And just anywhere above here, does not have to be even with this one. Okay, and then another min. This one's a max, and then another min here. Okay, and then I'll kind of fill in f around it. All right, so here is a possible graph of f. Okay, this next one looks a little bit interesting. We have 4 horizontal segments. If f prime is horizontal over a segment, over an interval, then that means that f has a constant slope over that same interval. Okay, so let's look at the values for this one. Here it appears, I'm going to start right here. So it appears that this is about y equals 1/2. So that means that f should have a slope of about 1/2 over this interval. And then here it looks like we're at 3/2. So here the slope of f is about 3/2. And then over here, f prime has a value of -1/2, so the slope of f should be -1/2, and then the slope of -3/2. Okay, so wherever I draw this, and I'm going to draw it down below, okay, I should have 4 linear segments that have slopes of -3/2, -1/2, +1/2, and +3/2. So from -2 to -1, I need a slope of -3/2. So we'll say that's, I didn't put any y values on here, so we'll say that's about -3/2. Okay, and then from here to 0, from -1 to 0, we should have a slope of -1/2. So still a negative slope, but not as steep. Okay, let me try and make that a little bit straighter. That's a little bit better. Not much. Hard to do straight lines on here. Okay. All right, and then from x equals 0 to 1, I should have a linear segment with a slope of +1/2. Now, remember, we don't know where this is happening. We could assume that the function is continuous, but really it's not something we know, so I could put that slope of 1/2 right here if I wanted to. Okay, and then for my slope of 3/2, again, that could occur anywhere. I could put that up here, I could put it back down here. It doesn't really matter because all I know is the slope, not any values. So it could be something like this. Okay, and now I would have to have open points on some of, like, I can't have a closed point here and here, or here and here. So really, we'll make a couple of these open. There we go. That works. Okay. So something like this, you could make it kind of like a jagged U, V shape if you want, but that's all we know is the shape, not the location. Okay, here we have another one that where f prime has a few x-intercepts. It appears that it comes back to 0 here, so we'll just assume that f prime continues like this. Okay, so if f prime is changing from, f prime is negative here. If f prime is changing from negative to positive slope means we have a min, okay? And then here we would have a max, and it looks like we're back to a slope of 0 here. So let's put our min here, and let's put our max here. Okay, and then it looks like it comes back to a slope of 0 on either end. So let's fill in between. Now, because we have a horizontal tangent on f prime, that means that f double prime would equal 0, meaning that we have a change in concavity on f. Okay, so we're going to have an inflection point somewhere in between there. Oh, forgot which point I was going to. Okay, so something like that. And then this one is still negative, but then it looks like it flattens back out. And then over here, still positive, but it looks like it flattens back out wherever that's going to happen. And I don't really know what happens after that, so we'll just stop like that. Okay, they might have asymptotes, they might continue, doesn't really matter. We can't see it. Okay, so f prime could look something like that, again, anywhere vertically. This one right here, we have a very, very positive value that becomes less positive down to x equals 0. We have a value of 1. Okay, so that means the slope of f is very, very positive, but then decreases to a slope of 1. Now, here, this does not hit the x-axis, so we do not have a horizontal tangent. We do not have a slope of 0 anywhere on f. Okay, we have a slope, I'm going to draw this one down below. We have a slope that is very positive, and it becomes less positive, and at x equals 0, we have, we'll say we have a point here. We still have a slope of positive 1, okay? So it's not 0, all right? But it looks like that's the lowest the slope goes. So that means we have a steeper slope to the right, okay? And then it looks like it's going to turn, but it really only goes to 1, and then it starts to get steep again. So something like that. Okay, for this one, we have a few x-intercepts. We have an x-intercept here, here, and here. Here, f prime changes from positive to negative, so positive to negative slope means we have a max on f at x equals about -2, and I'm going to put that right here. Okay, and then so the slope is positive, and then it is negative. Now right here, something a little interesting happens. F prime is negative and comes back to 0, meaning we have a horizontal tangent on F. However, it then continues in the negative direction. It goes back to being negative, F prime does, so that means the slope goes back to being negative. So we have something where this has a negative slope, and then let me draw it so I don't run into the origin here, okay? So it's a very negative, and then it's less negative, and then it does have a slope of 0, and then it says, just kidding, I'm not going to turn around, I'm going to keep being negative all the way until, and then we do have a min, because f prime changes from negative to positive, all the way until we get to here, and then we're going to be positive again. So something like this. I need to fill in this side. Okay? Not a very smooth one. Let me draw a better one down here. So increase, and then we have a min, and then we have a horizontal tangent, and then just kidding, we're still decreasing, and then we turn and we come up. Okay, something in that kind of a shape. All right? Okay, and then for this last one, we have what appears to be a cosine graph. Now, if we think about what we did on the other side, we know that the derivative of the sine curve looked like the cosine curve. So if this is our derivative, then the other graph, the graph of f that we draw, should look similar to that sine curve. But again, we don't know where it is. It could be different vertically, okay? So this one has x-intercepts at these 4 places, meaning that F will have a, so positive to negative, we'll have a max here, and then a min, and then a max, and then a min, okay? And it looks like everything's pretty evenly spaced out, so since I know what that graph should look like, I'm going to draw that down here. So we'll have a max, and then we'll have a min. This is, since I know I'm drawing like a sine curve, this is kind of like my midline here, okay? So min, and then another max, and then another min. All right, something like that. Okay, so like I said, this direction is definitely tougher than the other way. Just do what you can, write down information that you know, write ordered pairs if you need to. Like if you're looking at F and you want to know something about F prime, write down what that's telling you, or vice versa, and practice.